Hello again, Year 7. Welcome back to our fourth lesson in common chemical reactions. This lesson is all about acids and bases. There is a practical towards the end of the lesson, which has two options. You are either able to do it at home with the permission of an adult, or you can do an online simulation, which means you don't have to run the risk of making a mess, and you can possibly test more things. Or if you're very keen, you can do both and compare them. But if you use a simulation, I would like some feedback from you onto what was good about it, what was limiting about it, to know that you're still thinking about it. Right, you'll do now is on this first slide, you've got a table with 3 different scenarios in it, and you have to decide whether or not they're a chemical reaction, and if they are, what the evidence is. Obviously, when you do this, start it, you will want to pause the video. Okay, you should have been quite clear here. Ice melting is a physical change. You start off with water molecules, you end up with water molecules, they're just in a different state, they're changing from a solid to a liquid. When you've got somebody exercising and getting hot, they are respiring, that is part of last week's lesson, that shows a chemical change. A drum being hit and sound being released, it's not a product, you're not making or a reactant, you're not making anything different, there's no substances being made, so that is a physical change. I'm sure we all got that. Let's have a look at our objectives now. Now there are 5 objectives here, but they're not too tricky. You've got revising the 3 types of chemical bond, knowing the law of conservation of mass, using a simulation to test pH, or you can do the practical if you prefer, being able to explain what an acid and a base are and name some examples. You need to know those. If you're naming them, you need to know them, not just through this lesson, but going forward. And there's a silly song at the end to have you practice vocabulary. And I know that last year's Year 7s actually had a group chat where they got together to practice the song together. They really liked it. You might want to think about doing that too, or you could even do a little video of you singing along to it, and we can see who can do the best video. Right, 3 types of bond. Now this is not 3 different types of James Bond, although these are all some very good films. You have got metallic bonds made between 2 metals. Quite easy, clues in the name. And they have delocalized electrons, which are ones that can move about between individual atoms. So they're not local, they are delocalized, they can move, and those electrons move between individual atoms of the metals and they make a bond. Ionic are when you have one metal and one non-metal. The metals give the electrons, the non-metals take the electrons. So they're actually moving from one to another, and that is making the bond. Covalent, made between 2 non-metals, and they are shared. Think about it as care, co, as in company. I have used the initials MIC, so I just think that's an easy way to help me remember it. And they actually go then from metals to non-metals, and in between you've got your ionic. Quite straightforward. Obviously you need to learn those. You can write them down, you can do some actions, you can sing it. You know what works for you by now. Let's go. Conservation of mass is really, really easy. You already know about the law of conservation of energy. You can pause the video here to remind yourselves if you want to. Don't forget your actions, especially that dab at the end. Now, in a chemical reaction, instead of having the law of conservation of energy, we have the law of conservation of mass. And mass is the word that we use in science rather than weight, because mass is the same, it's the number of atoms, and that will be the same wherever you are in the universe, whereas weight relates to gravity, so that will change depending on the planet or place that you are. So the law of conservation of mass says that the mass of the products after reaction equals the mass of the reactants at the beginning. So if you have the masses and you add them up, you'll know what the mass of the reactants are. You've got the products at the end, you add those up, it will have the same mass. Sometimes people get caught out by forgetting that if one of the products is a gas, it might have moved away. You might not have captured it during the reaction, and then it can look as though the mass hasn't changed the same, hasn't stayed the same, as though it's reduced. But we won't get caught out by that because we're smart and we're going to remember that gases are out there and they also have a mass. If you want to prove that gas has a mass, have a can of Coke or lemonade, other fizzy drink supply, and put it on some scales in your house and get the weight in grams. Open the can, listen to the fizz sound. That fizz sound is not a chemical reaction, it is bubbles of gas escaping because they were held in the can under pressure by the fact that you've got a completely enclosing surrounding, so can't go anywhere. As soon as you open it, because they're gas molecules, they want to be as spread out as possible and they will go out of the opening. You will find that after 5 to 10 minutes the weight of your can will have reduced, even if you haven't drunk the drink in there, which might be hard on a hot day, but if you don't drink it, it will still reduce because of the weight, the mass of the gas that was in there. That's nice, isn't it? The mass of the gas. Right, moving on to our acids and bases now. If you have got some coloured pencils, you might want to draw this out yourselves in your books or on a piece of paper to know the colours, because this is something you're going to use a lot in science when you get back to school and you're able to do practicals again. We're also going to use it later on today. The pH scale, if you have a look, is pretty similar to those rainbows we've seen everywhere, so it shouldn't be too tricky. So we've got a red, then an orange, then a yellow, then a green, then a blue, and then lilac-y, and then purple. At this end, the red and the oranges and the light greens are acid. So they're described as being acidic because that's an adjective to describe being an acid. If you are up the other end, they are described as alkaline, and in the middle, not one thing or the other, is neutral. And the way, when we measure these, it's a way of grouping substances by a property. The property is how acid or how alkali it is, and that is called pH. Now, what you do need to notice is a little p and a capital H. The H is a capital because it stands for hydrogen, and we know the first letter of an element is always a capital letter. So please make sure you get that right. No lowercase h's here, that will be a problem. And it's measured using indicators. You can use a special paper called litmus paper, or you can use a solution. So that's a liquid that it's got water and it's got something else dissolved in it. That's what makes a solution, when something is dissolved in a liquid. In this case, the liquid is water. And the universal indicator solution looks sort of like brown colour in the bottle. It comes in a little bottle with a dropper, and you test an acid or a base, and it will have those colours depending on what it contains. So you can get things will be either acidic or neutral or a base. They can't be more than one. They can only be one or the other. 1 to 6 are acids. The smaller number is stronger. So an acid with a pH of 1 is a stronger acid than one with a pH of 4. 7 is in the middle, it's neutral. And 8 to 14 are the bases, and with the bases, the bigger numbers are stronger. And an alkali is when you have a base that has been dissolved in water. So all alkalis will be bases, but not all bases will be alkalis, because some bases aren't dissolved in water. So that's the difference. You need to be quite precise with the words you're using there, whether it's an alkali or a base. There's some examples of things that you might know about. Vinegar that you put on your chips is an acid. A bee sting is an acid. Water is neutral. That makes a lot of sense. You wouldn't really want to be swallowing something acidic or something particularly alkaline, because they wouldn't be very good for your insides. And soap and wasp stings are both bases. So actually, although a wasp sting and a bee sting feel very similar, they're both very painful, they're actually completely different chemicals. It's quite an interesting little thing there. Now we've got a practical coming up, and we are going to have a go at testing pH. We will need to have a table drawn first. So we're going to have a substance, column, we're going to have a column with pH. Remember that should be a capital H. Oh, made a mistake. Let's change that, capital. Always check your work, kids. It's very important. Then you're going to look at the effects of diluting it. That means adding more water to an existing amount of substance, and notes about anything you notice, and possibly also the colour when you add the indicator. And you've got two options. You can either do this through the simulation that I'm giving you a link to, or you can do it with a practical at home. If you're going to do a practical at home, you need to be sensible, you need to be safe, you need to make sure that you have checked with a grown-up and they are happy for you to do it. They might even want to do it with you so you can learn together. That's always the best way, I think. Now, if you have a substance, you mix it with water, that would make it dilute. Think about making up squash. If you have squash straight from the bottle, oh, that is too strong. Nobody or very few people can drink it and enjoy it. However, you mix it with water, you make it more dilute. You've still got the same amount of squash, but you've got a bigger volume because you've added water to increase the volume. And that makes the molecules of the squash spread out more within the water mixing in between the water molecules, and that will make it dilute. It's still the same amount of squash there, but it's more spread out. Okay, so diluting is spreading it out in a bigger volume. Now, once you've got your table, you've got your 4 columns. Remember, when we do a table, we write our headings first, then we do the lines. It helps us make sure the words will fit in. We're going to have a look at the practical. You can, of course, pause the slide here while you do the table to make sure you've got the spellings correct. Remember that capital H and PH, please. Okay, so 2 options, each one is on one slide. First one is a simulation, which means you have got something online that lets you do the practical by moving equipment and adding solutions, but without making any sort of mess at home. This one has come from the Royal Society of Chemistry. I will put the link separately on Go for School so you don't have to do it from the PowerPoint. I'll also put it into Teams for you. Use the link to run the simulation. You can choose a substance that will go into a beaker. You then have a pH meter. Remember, meter means a measurer, so a pH meter that you put into the solution to measure the pH. You are also able to add water to the solution. That's going to dilute it. Remember that vocabulary we had before, diluting, where you spread out the molecules into a larger volume. And I had to fiddle with this a little bit, so I'm putting it on here for you. There is a little stopper on the picture of the equipment, and you need to pull it to the left. So you need to click on it and then slide your mouse over to the left to open the stopper to let the water add in. When you finish your first test and you want to put something different in the beaker, obviously you're not going to run it over. You're going to go down to the bottom. There's another little stopper. You pull it to the left to empty the beaker. Then you can start over. One advantage of a simulation, I'll tell you now, is there is no washing up or clearing up. Okay, well, if you use the simulation as well as recording the results of your practical, have a think about, is it helpful? What is helpful about it? And do me 2 or 3 sentences to let me know what your ideas are. There won't be a lot of right or wrong with this because some people might like it, some people might not, but it's there as an option. If you want to have a go in real life, then you can make your own indicator solution at home using red cabbage. I have checked online and red cabbages are currently available online from Sainsbury's, hopefully. It needs to be red cabbage, not green cabbage, not broccoli or cauliflower. It has to be red cabbage. You have to chop the cabbage up or possibly grate it. If you've got a food processor, you may be able to chop it like that. You need to check with your parents. You will not need the whole cabbage, so you can all have cabbage for dinner. I can hear the cheers and haverhill now. You put the cabbage in the saucepan. You pour over water that is already hot from a kettle. Don't pour it from one saucepan to another. You simmer it for 10 minutes. Those of you that haven't done your cooking at school yet, simmering means you've got small bubbles, but it's not big bubbles like you get at a boil. When you've simmered it for 10 minutes, you can switch the heat off, and you can pour the mixture through a sieve so that the cabbage will stay in the sieve, and you'll just have a coloured liquid in a jug. This will be very hot. You may need an adult to help you with this. Leave it to cool for half an hour before you use it. If you leave it for longer than that, that's fine. Do not expect to leave it on the side for 4 or 5 days and it'll be fine. That would not be good. Then all you need to do is get something small. You might want to use a little small dish. You might want to use an egg cup. Put a small amount of your test substance. Add to it about 20 ml, which is 4 teaspoons of cabbage liquid. If you have got one of those syringes that I use to give medicine to younger children, that is a really good way of adding a small amount of liquid to something, but obviously do check with an adult before you do that. When you've put your cabbage water indicator in with your test substance, give it a chance for the colour to form, and then have a look to see what the pH is. Now there are slightly different colours for pHs with the homemade indicator solution. I have got them on the next slide. What you may want to do if you're going to try the practical at home is to actually just print out the slide that has got the pH scale for the homemade indicator on it so that you can have it to hand, or you might want to have that screen showing on your computer while you do the practical, but obviously be very, very careful not to get liquid onto a computer or a tablet. It's not a good idea. So here is the pH scale. You see there are different colours. It starts from red and then it goes through pinky purples and blues to greens and yellows. So it's not the same as it is for universal indicator. Each indicator will have a different range of colours for the different substances. So it's important you know which ones you're doing and you use the correct scale to check your pHs. But this is quite handy because you can do it at home, and it's always good fun to be able to do a practical at home if you can be safe and sensible. So that's your scale. Don't need to say much more about that. Now, acids, general information, they can be corrosive. That means that they can sort of eat something away, and they can damage other substances. You've probably seen a battery that has leaked and it's got sort of white powder or maybe sticky liquid around it, and that's because acids have got H+ ions in them. Ions are something you learn a lot about in Year 9. Examples of acids in real life: you have battery acid, both in batteries that you use for power in small hand objects and also a battery in a car. You have acid in your stomach, which is designed to actually kill off any bugs that are in any food you eat, as well as to start the process of digestion by actually breaking up the cells, hence the fact it's corrosive. Coffee is actually an acid, which is why they say not to drink too much and to make sure you brush your teeth regularly, because you can damage your teeth from too much coffee. And slightly grim, urine is also slightly acidic. Looking now at bases and alkalis, they will react with acids because they're sort of like an opposite, and if they have that reaction, it's called a neutralization reaction. We'll learn more about that next week, so I'm not going to say a lot today. If you have metal oxides and metal hydroxides, remember when we were writing out the names for different products of reactions, we had oxides and hydroxide. They're types of bases. They can be caustic and may burn or corrode. So caustic is a bit like burning rather than corroding, but they can still actually damage things. And these have got an OH- ion. Notice this is a minus and acid is a plus. Gives you a clue as to why they're opposites. And examples of this are drain cleaner, bleach, which you put down a toilet, soap, baking soda, which you can use to make cakes grow, specifically gingerbread, I believe, and your blood is slightly alkaline. It's pH 7.4. Remember, 7 is neutral, so it's slightly alkaline. Okay, so that's some interesting examples. I said to make sure you know some of those, and please make sure you've got some notes or some flashcards or a poster or a mind map, whatever works for you. Now, last bit. This is a bit you'll really like. This is a silly song. Vocabulary in it goes a long way past Year 7. It will go all the way up to GCSE, maybe even the start of A-level acids and bases. You will probably already recognise the song or the tune from a few years ago. It is very silly. You may want to listen to it first, get your giggling out of the way, then phone a friend to sing it together, because this is in the best traditions of YouTube. It does actually have the words on the screen to help you. And if you want to make a video or recording of you singing this song, or indeed better still, be really creative and write your own song, please have a go. Final question, a little bit of a silly one, but it's a proof you've got to the end of the video. What do you think is the pH of James Bond? There's a little bit of a clue there. Think about his number. Okay, so quite a lot to do this week. Interesting, fun, real life uses here, because we know that lots of cleaning materials and other substances around the home are acids and bases, and it's a good idea to know about them and their properties and how to keep safe around them. So, usual place. This will be on Go for Schools. This will be on Teams. You can submit your work through Teams, and then I can get back to you on the feedback option. If you're really struggling with Teams, please feel free to send me an email. Have a great time. Stay safe. Hopefully see you sometime soon, Year 7. Take care. Bye for now.